Hi, welcome to the Inflectra webinar on Becoming Agile in Software Testing, the Government Edition. My name is Adam Salmon, and I'm going to be your presenter today. In today's webinar, we're going to be looking at the Agile Manifesto and specifically the role of testing. We'll look at some of the specific challenges of doing Agile methodologies in the government for both defense and civilian projects. We'll look at the role of methodology, the acquisition rules, how you would enforce traceability of requirements, and independent verification and validation. We'll then look at some practical examples using our SpiraTeam test management and ALM solution, and then we'll automate some test cases using our Rapise automation tool. And after that, we have some Q&A. So first of all, last week we sponsored the Agile in Government Summit here in Washington, D.C., part of the ADAPT meetup group. And during that event, we talked to a lot of people, customers, prospects, and industry analysts. And we learned a lot about the government and some of the specific restraints and conditions that happen. And so in today's presentation, some of what you're going to see will be based on our experiences priorhand of our customers using our products in the government, in defense and civilian agencies, but it also does include some of the information we learned from experts during that summit. So first of all, Agile. Why is it important and why is testing so important? Well, before we get into the details of Agile, we have to look at why do projects fail? And there are three main areas of risk we have found in our studies that cause projects to fail. And when I say fail, it could be that they're late, it could be that what is developed at the end is so far from what was designed that it's not needed. And really, there are three main risk areas. One is the conceptual risk. This is, do we understand what we're building? This is particularly hard when you're building something very new, something that hasn't been done before. So it could be a brand new military system, a mission system that's going to be a capability that's going to be leading in the world. It could be a business application that's going to tie together a bunch of different healthcare systems, legacy, personnel systems, Medicare, Medicaid. It's never been done before. Do we know it's going to work? Is it the right thing? It's a health exchange. Well, these are new. What is a health exchange meant to do? What's it meant to look like? And so there's always conceptual risks around building anything new because you have these ideas, you have these requirements, but what you end up building, whilst it may be on time and it might be what was written on paper, won't actually meet the needs. And you don't know that at the beginning. You may not know that till the end. The second thing is technical. So even if the concept is sound and the end product would make sense, maybe it's impossible to realize. It could be perhaps the data itself will come from too many systems and be too slow. Maybe we can't pull that data for a variety of technical reasons. Maybe what we're looking to do is not technically feasible because the hardware doesn't yet support it, or maybe there are policy reasons that the data can't be automatically pulled in. And those technical aspects are hard to see ahead of time. They could be performance, they could be security, they could be limitations of resources, just depends. And then the third area is schedule, the one that people tend to focus on, which is even if we can get a concept that would be appropriate, even if the technical solution will be feasibly work, it will be years late. And so by the time it's delivered, it won't be the right thing anymore. And the industry has moved on. So Agile can help solve some of those big risks that derail projects. So how do we do that? Well, the first thing is conceptual risk. People have a hard time understanding something in abstract, but when they see it, they quickly grasp the concept and can give feedback. People have an easier time, I think, saying, oh, I don't want it to work this way, I want it to work that way, than looking at a whiteboard or a series of requirements in a big document and say, oh, these requirements don't make any sense. So Agile helps because by creating small prototypes, small increments up front, especially if you focus on some of the more conceptually risky parts, prototyping out a functioning system that does one small use case but would give someone visibility into what the process will look like, they will quickly see that whilst it's sounding good on paper, in practice it's not going to work. And so that can really reduce your conceptual risk. Second thing is technical risk. Now, you can do a lot of research. You can research technologies, you can research systems, but nothing really proves out technical risk like trying it for real. If you're going to have to integrate a bunch of systems, mainframes, legacy systems, new applications, do database transformation, ETL data loading, all of that stuff is potentially technically risky, but you can try it out ahead of time. And especially when you're building a solution, it is tempting to build the sexy functionality first and deal with the integrations and the reporting and the technically hard stuff later. And that's obviously got to be balanced with conceptual risk. So when you're starting to plan out, try and demonstrate in the early increments things that are conceptually risky so that someone can see, oh, I see what this functionality is going to look like, but do balance it with trying out some of the technically risky items, the most risky items early as well. Don't leave them till the end. It's unfortunately a tempting thing to do, to build a great system and then try and integrate it later, but then if that integration doesn't work, the system is worthless. So by proving out the technical risk first, using spike solutions, prototypes, you can change course before there's too much money has been invested in the functionality. And you could throw out requirements because in reality, though they are great conceptually, they're just not going to be feasible right now. And then in terms of schedule risk, Agile really helps because you take a large set of requirements and user stories and you break them down into small sprints or iterations, and those can be planned out. And so if something takes longer than planned, you don't have to keep pushing the date out. You could scope down. You could say, we're going to release this minimum viable product. We're going to get it out there. We're going to get public comment, public feedback. We're going to get it into the hands of the warfighter if it's a mission system. And you can get that feedback. And if things that need to be changed, they can be changed. But also that you're able to get functionality out earlier and deliver the value earlier. So if some of the later pieces of functionality do take longer, the whole schedule isn't being held up just for those. So those are some of the reasons why Agile is a real benefit in any environment, but particularly in the government. Now, software testing is a key part of the Agile methodology. If you look at extreme programming and some of the early engineering practices that went into Agile, testing is one of the most important disciplines. Unfortunately, it's often thought as an afterthought. You get your planning game, you put your requirements together in your user stories, you get your Kanban board up, your Scrum board, you assign the developers, and the developers go build the functionality, and ideally, they do some testing, they do their unit tests, and they can do test-driven development. But testing is a key part of Agile. You have to make sure that you understand the realm of the tests that you have to do and then do them early as part of each of the sprints. It's tempting to have the developers do just their unit tests and run them the happy path as they're writing their code, and then it's tested, let's go live, and then it doesn't work in real life. So it's not that simple. You have to make sure that you have acceptance tests. So every user story is supposed to have at least one acceptance test, something that would actually show an end user in human readable form what this is meant to do. What is the value of this user story, this requirement? The test describes how that value is understood and how it's realized. If you can't write an acceptance test, you probably haven't described or defined the story well enough. It shows there's actually an issue in the requirement in the user story. Unit tests should be run all the time. You should have a good set of fast tests that can be run continuously, but that's not sufficient. You should have automated longer tests, scenario tests, integration tests, API tests. Anywhere there's risk in this technical risk in the system, your testing will identify that risk early and reduce that risk. And unfortunately, it isn't just functional testing. Things like performance and security need to be done at the beginning because those are much easier to fix as you're writing the functionality, as you're building the increments of functionality, than trying to do it at the end. Anyone who's ever had to do performance engineering at the end knows it's a disaster. Same with security. They need to be built in as actual stories, as actual parts of each iteration and sprint. And this diagram, I think, encapsulates this, which is that you have to test those 8 boxes, the realm of testing, but you have to do it in an agile fashion. And you could have some iterations or sprints that are specifically focusing on certain aspects of this. For example, you could have a Section 508 sprint where you're basically going to make sure and do a series of tests and updates and refactorings to make sure it's fully Section 508 compliant. Other kinds of testing will be done in the course of the development sprints. For example, unit testing is being done all the time. Hopefully, integration testing is being done all the time as part of continuous integration, but acceptance testing may be done at the end of certain phases. Maybe you'll have 3 or 4 sprints, and now you come to a point where you want to bring some users in who actually may be the realistic end users of the system, and they need to do some testing. So Agile is flexible. You don't have to have every phase, every sprint being exactly the same. You can have some be just classic development, unit testing, integration testing. You could have a theme for a particular sprint, which is more testing oriented. The functionality, the changes are primarily based on what comes out of that testing. Now, when we talk about testing and Agile in the government, there are some unique issues to deal with. So, the first of all, and this is from the DoD 5000, this is the way that systems have always been built. It's traditionally been a very waterfall-based approach. You have an initial concept, you spend much time writing about it, you do a lot of research, you then do some prototypes and do some technology development to try and understand it. And that's sort of Agile because you do have the idea of spike solutions and prototypes. And then you do some kind of demonstration. And then once you've done this demonstration, you throw it all away and you start again with the live development and the live production, and then ultimately it gets fielded into support. So there are some Agile elements being infused into this traditional process, but it's not truly Agile. You're still really having these discrete phases. If you're building a prototype that's thrown away, that's not the same as a spike solution that is part of the core system. You're not really refactoring, you're just demonstrating. And obviously, you have to be able to fit into the policies and the methodologies, but there are ways to take some of the Agile approaches and use that. So when you do an initial prototype, you design it to be part of the actual solution. It's not a throwaway prototype. So by just changing some of the way you're engineering the system and how you approach this, you can still follow the 5000 model, but you have to make sure you're smart about it. So you're not just doing a series of separate waterfall into phases. You're actually following an evolutionary system where as you start to define the system, what you're building is part of the end result. It's not a throwaway. Another major issue we come across are the acquisition rules, which is that if we have a couple of vendors, they design the requirements, they write a specification, it then gets tendered out for development, and then some other vendors will bid on the development of the project, and they'll then take those requirements and then build to those. And at the end of the development phase, another set of vendors will do the independent verification. And those IV&V vendors could be the same as the requirements vendors, but definitely the guys in the middle, the development people, they cannot be anyone who wrote the requirements, and they cannot be the people doing the independent verification. This leads to many problems because the requirements are written on paper, they're defined, they're described, they become the contract. You then go into development, and then how do you become agile how do you work with the customer to take functionality and change the scope and iterate and get feedback if it's all locked into the contract? And then when you go into testing, the testers will take those original requirements from the very leftmost box and then test the system against those. Well, that's also a problem because if you're changing the requirements, you're listening to the feedback, you're building some solutions, you're iterating the design. How do you do that if you then have to test to the requirements at the very beginning? So the acquisition system doesn't make it easy, but there are ways around that. What you can do is, first of all, in the requirements phase, you can build in some of the initial prototyping. You could even do some of the spike solutions so that the requirements don't end up being a set of giant documents, which is the traditional requirements. They could become the first increment of a system, which is a sort of a prototype. And then that can be handed off to vendor A, B, and C to take it on further. And that way you still have the avoidance of an organizational conflict of interest. You can still have those vendors if they all get access to the same initial spike solution, and whoever wins can then move forward. And the requirements in the contract could be designed in a way that do allow them to be changed. The requirements are really the goals and this working prototype. And similarly, when you get into the IV&V side of things, the IV&V team could take the requirements that were taken from the initial phase that were then iterated on during development, and they could then do independent validation at key points in the development. So at the end of every certain number of sprints, you could have the IV&V team pick up what's been done and do the testing, but it's not done right at the end 3 years later. So there are ways you can structure the acquisition process and the Agile methodology together, but it's not something that you can just assume is going to happen. You have to be very careful, be very mindful of what your intention is. Do you want to have requirements locked in stone? Do you want them to be flexible? Do you want to give the vendors who are bidding on it an actual working prototype, something that they're actually going to use as their core to start with, so that way they're not starting from scratch and completely throwing out all the information and knowledge and feedback that was gained in that first phase? And the last thing that's quite tricky when it comes to these projects is requirements come in lots of different forms. So in a software project in the commercial sector, the requirements are whatever the customer wants. You can go into a workshop, you can describe the requirements, come up with whatever you wish, and those are your requirements. And you can then throw them out during the development. Now, in the government sector, similar to what we've seen in health, life sciences, and finance, is there's lots of laws and rules. So there are rules about what you have to be able to follow. Different types of system follow different laws. Most business systems have to be Section 508 compliant. Mission systems have to have traceability of your requirements to each test step. You have to have a lot of documentation and paperwork. You have to have various statutes around security, various statutes around privacy. So your requirements come from both the system being built, but also the legal and statutory context there within. So you do have the ability to be agile. You can write user stories. You can change the functionality. You can have feedback, but you do have to make sure you tie things back to the laws and regulations so that when the system is ready to go live and is being fielded, you actually have that paper trail in place. So you don't have to have the IV&V team come in and spend months and months just documenting everything that should be written at the beginning. So what we have found is if you can use tools to help you capture this information, and even though you're running an agile project, you're also being able to tie things back to some of the overarching requirements. When it comes to the end, you're saving a lot of time and complexity and having to go back and write all this paperwork just to follow the compliance trail. And then lastly, one of the other things we heard at the conferences and we saw in some of the presentations is lots of tools are everywhere. So a large program is going to have many different teams, many different vendors working on many different teams, and in each of those teams, you're going to have a variety of tools depending on what the vendors have chosen. If it's working across different departments, it could even be different government agencies using the different tools. So in this example, we've got some Microsoft, Jira, some Doors, and some other tools, all being used by different teams. And the question is, how do they work together? Each of those tools is a separate collaborative system. When you're talking about requirements management, maybe they're in one system, then they give it to another team. How do we actually have those tools work together? So it isn't just a question of having the right tools, it's having the right tools working together to achieve the objectives. So that's a little bit of the background of where the problems are. Now, how can we help? And then as we go into the demonstration of our software package and how it can help, we have some different tools here. And today we're going to be focusing primarily on SpiraPlan and Rapise. SpiraPlan is our enterprise agile planning system, and Rapise is our test automation system. And the focus is primarily on SpiraPlan, but a little bit on Rapise as well, because test automation is a key enabler of agile testing. There isn't time to test everything by hand. You do need test automation. And when we look at that suite of ours, we don't live in isolation. As I mentioned before, there are so many different tools being used out there. You need to have systems that can work together. So these are some of the tools that our customers are using our platform with. For example, some of our customers are using SpiraTeam or SpiraPlan with Jira, with TFS. They're using Enterprise Architect for some of the modeling. They've got some legacy requirements indoors. They're doing a variety of different types of automation testing. They're doing unit testing. They're doing load testing, which is good. Their code lives in a variety of different repositories. And they need to have these tools all work together, but you have a common place where they can see that traceability. And so that's what we offer. And what I'll be going through in the demonstration section is, first of all, requirements and test validation. How can you load requirements into SpiraPlan? How can you structure them in a way that lets you track dependencies and track requirements and user stories and policies and other aspects of non-functional requirements? We'll talk then about how you can do test traceability. And for many applications, test traceability is all about tying requirements to test cases. But also, as we've learned from a lot of our customers in the mission side of things in the defense space, you also need to be able to tie requirements directly to test steps. And that's a very unusual requirement. And unfortunately, many tools can't do that. So we actually added functionality after listening to our customers to specifically provide that feature. And we'll show you that piece in action. Another really important aspect is sharing requirements, because you may have different projects and which are really different teams working under one giant program. A lot of those requirements need to be shared and linked. And that's an important piece, because you may also have a single project where you're going to store all of the policies and rules, Section 508, OMB 300, DoD 5000. There's a lot of rules and requirements that are just stated for all projects. So rather than having to have that in every single project, we can have a shared set of policies that we'll use. Audit trail is key also. Any government project is going to be audited, whether it's going to be within the agency, the department, GAO, the IG. Anytime there's a large mission critical system, it's going to be audited by a variety of different agencies. You need to have an audit trail in the system. It needs to support your auditing. If you have to do this by hand every time there's an audit request, that's going to derail the project. So you want to have tools that make the auditing seamless. Whenever you use the system just to do your daily work, there's a full audit trail across all the different aspects and disciplines. And as I mentioned, test step traceability is a unique feature needed for the mission systems, people building avionics, building aircraft frames, embedded systems, workforce systems, any type of system that's involved in the mission environment, whether it's land, sea, or air, they typically have to be able to tie every single requirement back to every step being tested. It's very specific. And that's not something that's being done on the business side of business applications, but it is unique to the mission systems. And so we do have that functionality. And if a lot of people unfortunately don't, and so they end up using these repositories of spreadsheets and Excel sheets that just fill the drives. And it's very difficult then when you've got all those information stored in Excel sheets to try and do an audit, to try and understand where you really are. How many of your requirements have you really tested? Has every step been covered? And that's really important. But at the same time, you do need to have agility. And so having the ability to have an agile view, be able to look at the backlog, looking at sprints, looking at releases, being able to be agile is really important, having that flexibility, but you need to have it with compliance at the same time. And that's an important aspect which may not be true in all industries. Finally, program management is a really key aspect because these programs are large and you need to have a way to have different teams and different projects with different vendors working on them, but they have to tie back to the common whole. And so we'll be showing you a little bit in the demo of how you would use program management functionality to be able to see the overarching schedule and to see how the different projects tie together. And then as well, I mentioned earlier on about automated testing. One of the things in Agile is that as you're releasing functionality potentially every 2 to 3 weeks, one agency we spoke to is doing, I think, 300 different deployments into production every month, which is huge, and that requires automation. You can't deploy and develop and test that quickly if you're relying on human testers. You need test automation to do that. And that doesn't mean automated testing solves all the problems. It certainly doesn't. But you do need that functionality of automated testing to be able to handle all the rote and routine cases, testing the system with large volumes of data. Perhaps you're going to try every single sign-up of a healthcare system with all the possible patients that you could have of different classes and types. So you'll use automated data-driven testing to test a lot of the known cases, and that will then give more time for a human to go in and do some of the extreme testing, edge cases, things we wouldn't have necessarily thought of in the requirements. And so automation is not solving the problem by itself, but it makes room for manual testing to be more focused, and it certainly contributes to more efficiency overall. So that's a little bit of the background of the context, and we're now going to move into the live demo portion. So I'll close out a PowerPoint and we'll go to the live system. So what we've done in today's demonstration, and this is SpiraPlan, which is our ALM solution, and we've created a project called Government Agile Project right here. And to start with, we went into the planning section and I went in and created a release with 3 sprints. And if you go into the system right now, you'll notice the requirements list is completely empty and the test cases list is completely empty also. So typically when you're using a system from the beginning, you'll have data in other formats. And so I wanted to show that. So here we have an Excel sheet where we've written up ahead of time some fictional requirements. So in this fictional requirements document, we've written some policies and guidelines. The system needs to be Section 508 compliant, needs to use some standard hardware, software. We then wrote some functional requirements. And for this example, we chose a military logistics system. Something I did in a prior life, in fact. And here we're going to track supplies, track assets, major assets, kits, assemblies, parts, and then people. So we were able to break down our requirements into a decomposed list of different items. So this is one of the benefits of SpiraPlan is you can have user stories, but you can also have a more decomposed requirements view, which lets you break things down in a more natural way. We've also prioritized them. And we've also estimated them. So that's available as well. And what we can do is then we can load these into the system. So we're going to go to our add-ins and we're just going to connect to our server. And here we are over here. So what we'll do is we're going to connect right here, put in the URL, We're going to connect, and then we're going to import the requirements into our government project. Okay. And there we go, it's loading it in. As it loads in, it's putting in the ID so we can do updates later. Okay, there it is, it's finished. And if we look into the system, go into SpiraPlan, and we'll just hit refresh. Oh, that's test cases. Let's go to the right screen. And there we go, there's our requirements. So we have here some requirements. We have policies and guidelines. These are the two. We have our function requirements. And if we wanted to, we could go into the website here and just add more requirements. So we don't have to rely on the Excel sheet. We can do things here, go insert. And let's add something else. So we have parts management, we have kits and assemblies. Maybe we'll have kit management as a sub element. And we'll make that, high priority. And maybe let's add assemblies as well. So these will be our requirements. Perfect. Now, if we go into our testing, those are empty right now. Now, the system does let you create test cases directly from the requirements. So some cases, either the test cases don't yet exist. We can go in here and say, tools, create test cases. We're not going to do that though, because in this example, we've got some test cases already written and we want to use those. So we'll go back to our test case view, go into our spreadsheet, and in the test cases tab, we can do the exact same thing. We can import our test cases right in. And these will be our test cases, and they're in different folders. And then on the right hand side, we have the different steps. And we've created some example steps. So we got a test to request supplies for the supply management, a test to approve requests, a test to create assets, edit assets, create personnel, edit personnel. Now we didn't write steps for all of them because it's a demo. In real life, they'd probably all have steps. And we can do the exact same thing here. We go to test cases, we do the export option, and it's going to pull it in. Wait for that to finish. Okay, those are our tests. If we go back in here and hit refresh, we've now got some tests. And I didn't really want my personnel management to be a top level item. I wanted that to actually be under functional tests. So that's easy enough. I can go here and I can say I want to move this under functional, hit update. There we go. So that's actually what I wanted. So I've now got my functional tests, I've got my asset management test, personal management, supply management, and they're all marked as not run because we haven't run them yet. And so from a traceability standpoint, we would want to go back in here and we actually want to then link these tests to those requirements. And we can do it one of two ways. We could go into here, supplies, for example, click on that, go to our test coverage, and we can say, let's add the test cases. We'll go to functional supply management, and these both test the tracking of supplies, hit save, and now we have a situation where this requirement will be considered fully tested when these two tests are run and passed, which is great. If we go back to our requirements page, we'll see the same thing here. That's our requirement, and that's our test coverage, which is great. And if we want to see the same thing in an Agile view, that's also possible. Just go into the planning board, and we've now got a planning board option, and we can look at the backlog, and we can see all the unassigned items we have. And these are our particular stories and requirements, and you can see they're listed here in a story card form. There is the option to show the test cases as well, if there are any. So we can see this one has 2 test cases not run. So you can see here right on this planning board view, the same information. There's our requirement, and there's our 2 test cases not run. The other nice feature this gives us is if we want to start doing planning, it's really easy. We can go into, let's say, release or releases. We only have one release, so actually just go to release 1. We can look at the unassigned items, and we can then pull those into the release. So we'll group by, actually I want to go to all releases first to get it into the release. Go to release 1, and let's say we're going to put these requirements, this one, this one, this one, this one, and this one. We're going to put these all into that release. That's the right one. So we'll go ahead and do that. So what we'll do is we're going to grab this, 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 and this, and we'll drag that down into release 1. And then we want to go into release 1, and we can group it by sprint or iteration. And let's, for the very first sprint, we'll do the tracking of supplies only. Maybe we'll do the kit management in sprint 2. So that's an example of using the exact same information we saw before on that requirements grid page to basically have an Agile view as well. So now we've got those planned out. The next thing we would typically want to do is do some testing and run the test cases. Now, before we do that, there's one other feature that I mentioned earlier on, which was test step traceability. So as well as being able to track the test cases, so this is our test case. You can see right here, it's got these 3 steps. And you can basically run the test case, and we'll go through that in a minute and run these steps. But you might want to link the steps individually. So right now, the whole test case is linked to that requirement right here. But if I actually go into one of the steps, and I'm going to control click on it to go to it, so say step 1, there is also the option to go into the requirements list and actually add a requirement. Let's say this is the kind of proving requests. Well, let's say we have to tie that directly back to tracking supplies. Hit save. We've now got test step level traceability. So you can track the test cases and the steps together. So we've now got our requirements, and we've got our tests linked together and our test steps linked together. As you can see here on the main page, we've got a whole bunch of requirements that are not covered. The blue section of this circle means they're not testable, and that's all these items right here. And we'd want to make sure we have everything covered. That gives us our traceability report. But then we also have 2 which are not run yet. So what we can do is we will want to run those, and to do that we will typically want to give those tests to someone, and so you need a testing solution for that. Those could be automated tests, or they could be manual tests, and this system will support running both of those. Those particular ones are manual tests right now, so we'll just create a manual test set. So we'll just call a simple manual testing phase 1, and we'll go in here. And we're going to add our tests, the 2 supply tests right here. And then I'm going to assign it to myself. In real life, you assign it to someone else. I'll assign it to me, hit save. And then we'll go back to my page, and I'll see my new assigned tests right here. Hit execute. And now I'd go through and actually run the test. And so the testing is a key part, and I'll choose the release in the sprint. We're in sprint 1, hit next. And the great thing is, as you run these results and the results get logged against, say, sprint 1 or sprint 2, they're going to roll up to the parent release as well. So you can have the test results against an individual sprint or iteration, but also they roll up to the parent release. So let's go in and say, let's pretend the very first one worked. We can go in and create new requests. That's good. And when we get to the second one, we click on a request, we get an error. We get a system error viewing the request, and we'll log a defect. So error running, or error viewing the request to approve. It's a bug. We hit fail, and we've now failed the step, and we failed the test case. And as a tester, we're done, which is great. And now if you go back into your requirements view for that project, we'll now see we have a functional requirement. There's our system tracking supplies, and we can see right here that the test coverage shows that that particular requirement has not been fully tested. One of the tests passed, one of the tests failed. And those tests could be a mixture of manual and automated tests. We'll show you the automation tests in a minute. And those automation tests will all report back in here. So this gives you a central view of all of the requirements in this project. They could be user stories, they can be policies, guidelines, all the different things that you might have. They're all going to be linked together here, and you can see all the results in real time. The other thing you might do is you might want to have traceability across the requirements. For example, maybe the ability to have to track major assets. Maybe that's tied to being Section 508 compliant, for example. Or, for example, maybe the kit management is tied. Well, actually, the kit management is tied to the major assets because the kits belong to the major assets. So we can go in here to kit management, and we can do lateral traceability as well. Go in here. We'll add an association to another requirement, and we'll add it to the assets. And we could even say there's a dependency because the kits depend on the assets being available, asset management being available, for example. So you can track dependencies right here in the system. And when you run your requirements traceability matrix at the end, you can then document, do I have all my requirements? What are the dependencies between them? And then also, what are the test dependencies? And if you want to see this in the Agile planning board, you can just go right back to planning board, and you'll see now we have that requirement in the sprint, and you can see right here, 1 pass, 1 failure. So you have it visible in the planning board or back on the requirements page. Similarly, if you go into the releases page, you'll see there that it failed against sprint 1 and it failed against the release. And so if we now go to sprint 2, we might retest that as well as testing the new functionality, and that's going to update the sprint 2 and update the parent release. And the system lets you have a large hierarchy of releases and sprints. For example, if we go into another project that we already have, you can see here we have a much larger hierarchy where you can have releases and sprints and minor releases and major releases. So you can model out a relatively complex program with all the dependencies and different iterations and releases and milestones. So if we go back to our project, obviously, when things fail, defects do get logged, and so the defects are available right here in the system. And there is traceability in the reverse direction. So this is the defect that was logged. It's going to be assigned to a team to fix. It could be the same team, it could be a different vendor, a different team, or part of the same team. And so it's really important to have the information be clearly articulated what happened. So whenever a defect is logged, you're going to have traceability to the exact step that failed, why it failed, where it failed, and what happened, so that when you actually look to test to fix the issue, you can make sure you're actually seeing the information that will guide you to fixing the right issue reliably. And if you go on the Associations tab, there's an option to see the original source requirement and the original test result. So if I click on that, from my defect, I can see here right away, why did this defect fail? Well, this is where it failed. It was on step 2. I was viewing the requests. If there's some sample data in the system, you can even trace back to the sample data, because potentially the sample data was what caused it. Maybe if we use different data, it would have worked correctly. And so that way, when you're testing edge cases, it can be helpful. So that's some of the manual testing. Now, as I mentioned earlier on, in an Agile project, you don't typically have time to test everything by hand. You also have to do test automation. And so in test automation, you're going to need to be able to run automated tests and have those report back as well. And we can do that in the system just as well. So let's say we go back into our test cases. If you look in the test cases list, I think we have one for logging in. And so we need to be able to test that we can log into the system. And so if we go into that, we haven't yet defined any steps for that one because we're going to do that purely automated. So let's pretend we have an application. So if we go over here, we actually have a sample application. It's not actually a military logistics system. It's just a simple website. And we're going to test that we can log into it automatically. So we'll open up the automation tool. And using an automation tool, we can tie this back to our original test cases and to our requirements. So what we'll do is we're going to go in here. Let's make sure we're connected first of all. Yep, that's correct. We're going to create a new test. And we're going to put it into our government Agile project. We're going to create a new functional test. And actually, we're going to use this existing one, the login one. And we're going to make that a web test because it's a web app. I'll choose my current browser. And automation tools, this is our own automation tool, Rapise. You can use other automation tools as well. And you would just want to choose a tool that appropriately tests what you need to test. If it's a web application or mobile or desktop, or an API, a SOAP API, a REST API, maybe it's a mainframe system. There are some tools that work better with different technologies. Rapise works great with mobile, web, desktop, and APIs. It's not really designed for mainframe applications and some embedded systems, but there are other tools on the market that can do that. And SpiraTeam can integrate with a variety of different tools, and just make sure whatever tools you use do support the technology that you're actually going to be testing. Now let me go into here, and I'll do JavaScript right now. And what I'm going to do here is I'm going to create my test. And so I can use this record option. I'm only going to record the login section. So I logged in. I want to verify I logged in. So I use this verify option right here to verify the login actually did happen, because the system can perform the actions, but I need to make sure it actually did work. And then I'll log out, and then I'm going to hit finish. Okay, that's a simple test. That's what it looks like. And test automation is not the focus of this presentation. We have other webinars that we've recorded on test automation. We can spend more time on that. But just for right now, we're going to save that back into the system. That's fine. Okay. And now we're going to run our automated test. And the key part is the traceability back to those requirements, because in the end, you need to be able to prove you tested everything and you developed everything according to the user stories and the requirements. So if we go back in here and we hit refresh, we'll see that we now have an automation script, which is great. And so we'll now go back into our test set view and we'll create another test set, which will be the automated testing. Automated testing. And we're going to add our login test case. And we'll save that. And we're going to schedule this to run right now. Automated on this machine. Oh, I need to create the machine. Let me come back and do that. I forgot to do this earlier, so I'm just going to create the machine. So name my machine, I'm a Doctor Who fan. Hit save. So that's good. And that's how it knows which machine to run it on. We'll save that. And then we'll just change the machine to TARDIS, and we're going to run it today. That's fine. Hit save. That's all we need to do. And then we'll basically close down the automation tool. And then we're going to launch the agent. This is the agent that actually runs the test automatically. And we'll just do force poll. It's going to run automatically on the background, but we're going to have it run right now. And so it's launching everything, and it's going to start firing up the automated test. And it's going to play back. And it should pass, hopefully. There we go, all done. To do the simple login, if we go back here and do refresh, we'll see that it's marked as passed. We have a test run, and if we go into the test run, you can see there, oh look, it passed, and we've got evidence. We've got the screenshots embedded, and we've got all the data that will happen. So from an automation standpoint, it's run the test for us. From an audit standpoint, we've got a full set of evidence here that our test passed, and the data and the screenshots act as the evidence for that, which is great. Then if we go back into our requirements view, we actually didn't link anything to that test case, so that's a mistake. So we need to go back in here and we can always add it later. So that was our login test case, and everything needs to log in. So what we can do is go into requirements coverage and say, well, you know what? This is testing that we can log in. So that's necessary for the tracking of supplies, tracking assets. For example, it could be all of these. So you can link a test case to many different tests, many different requirements, which is great. So now if we go back to our requirements view, we see the green show up. Now, obviously, in real life, we'd obviously want to have other tests because that's not a sufficient set of tests. We've just tested we can log in, which is one of the requirements of each of these, but it isn't necessarily sufficient. And so what we really want to do is make sure we have all the tests linked and we don't have any tests that are missing. And so the question is, how do you find that? Well, that's really easy. You can go into the reporting view and you can run a traceability matrix. And that way you can make sure that all your requirements are linked and all your test cases are linked and there's nothing missing. And so we'll go in here, we'll choose PDF. We're going to run just a standard report. We don't need to filter it. Hit create. And we're now going to get a requirements traceability matrix, which shows us all of our requirements, all of our tests, make sure everything's been considered. And if we go here, we're going to find out, well, these are our requirements. They've mostly got test cases, but we see one test case supporting all of them, which is this login. And we see all these other test cases that are completely empty, like creating assets, editing assets, personnel, and yet we have these personnel requirements. So if we saw this in a real environment, we know we're actually not in good shape. We are missing a lot of connections in traceability. So we need to go back in, and to do that, we can just go into the system, and we can go back into our test cases view, and we could, for example, go to the asset management, click on that one, go to requirements coverage, and then we just need to go in and add that to track assets like that, for example, and then fix the traceability. So you can do it in both directions. You can do the traceability from the test case back to the requirement or the requirement forward to the test case. One nice feature we do have, though, which is worth mentioning, is that if once you've got everything linked together and everything's being approved and ready to go, then if the requirement was to change, one thing you want to do is make sure the test is still valid. Suppose we have a user story or requirement, we review it, we decide that really it's not particularly good, we're going to split it in half, or we're going to change it in some way. Maybe we've already written the acceptance test. Sometimes people forget the tests and they get left and they're out of date. And very quickly you can have these stale tests that don't really accept that requirement anymore. They may have done a month ago, but they don't anymore. Well, if that happens, if the requirement does change, we automatically flag it as suspect. So that way it's filterable. You can find all the suspect test cases and then do a quick review to make sure they're still accurate. And that's an important feature we do have to make sure you can ensure compliance for all the requirement changes you've done, especially in an agile environment where you are changing things much more frequently throughout the life cycle. And then the last thing we have in the system is powerful reporting. So whatever you're putting into the system, you do need to get data out of the system. And so we do have lots of reporting options. So you can report both using custom reports and standard reports. And that way you can get your real-time metrics as the project progresses. And the other thing that's really important at the reporting level is being able to run across different projects. So if you go to, for example, a project group in the system, you can report across multiple projects to get a program-wide view. In this case, we've got several projects underway, and you can see right here the requirements test coverage for each of them. You can see the test results for each of them, the progress, the defects. You've got a portfolio view of all of your different projects. Furthermore, you can look at the releases and all of the milestones to see how is each of the products and releases progressing. And that way you can track your entire program and make sure that everything is fully tested. There's traceability for everything in the system across all the different projects. And we can also do that in an Agile planning board view as well at the program level. So we can do a program view and we can say, look at all of the products in our program and even do it by project like that. So that way you can see all the different requirements and stories by project and see where they are. So that's the end of our planned presentation. And so now I'm going to open up to the Q&A. So if you've got any questions, please feel free to raise your hand and I can unmute you. Or if you'd like to ask it through the chat window, I'm more than happy to read out the question as well. Okay, the question is, can you describe an entrance point into your tool set? Entrance point as in how you start using it with an existing set of data. Okay, great question. When you say migrate, are you using other tools or are you using things like spreadsheets? Some of both. Okay, fair enough. So the answer is, for spreadsheets, the simplest answer is we have the import tool. So for example, this is our spreadsheet. Will let you pull in requirements, test sets, test cases, defects, tasks, each of the different artifacts in the system. And I haven't even shown you the whole breadth of the system. There's a task management module as well. You can import releases and sprints. So all of the artifacts you saw in the system can be imported from a spreadsheet. We also have the same thing for Microsoft Word. And so if you go to our website, and you want to know more about all the options, you can go in here and say add-ons, SpiraPlan. And we do have import tools for Excel, for Word, for MS Project as well. So if you have an MS Project plan with requirements and tasks, you can import from MS Project. We also do support Google Sheets, which is becoming more popular as well as Excel. That's another option we have. And then for existing tools, we have migration tools for, first of all, the HP Micro Focus set of tools, which is ALM, Quality Center, Microsoft Test Manager, TestRail, QC, Test Director as it was known. We also do have import tools for some requirements management software packages, things like Enterprise Architect. So if you have it in EA, if you have it indoors, we have those. JAMA is another tool we've come across people are using, less contemporary tool but still widely used is IBM Requisite Pro version 1. We also can pull in data from using our data synchronization tools, also from TFS, also from Jira Atlassian products suite, and other bug tracking tools like Mantis, Bugzilla, Redmine, IBM Rational Team Concert, ClearQuest, FogBugs, and a bunch of other different tools. So there's a variety of different tools we have to move data in. And in addition to those, If you have a tool that's a commercial tool, we do add to our list as a customer suggests them to us. For example, we're going to be adding integration and import tools for ServiceNow, which has become increasingly popular. And then also we do have a robust set of APIs, both SOAP and REST. So if you wanted to code an integration, maybe it's a custom in-house tool, you could use our APIs to directly load the data in yourself as well, or just use the spreadsheet. Thanks for watching today's webinar. I hope it was helpful. If you'd like to learn more about software testing, application lifecycle management, or agile methodologies, please subscribe to our YouTube channel.